All right, so today we are going to go over the Profiler software with Shannon Davis. Shannon Davis owns Davis Technologies. He is the creator behind the best traction control that you can buy. You've bought your traction control system, and we are going to hang out with Shannon for roughly an hour and learn all about how to set this thing up and make it work and how to go make fast passes. Shannon, are you with me? Can you hear me?
Yes, sir. I'm here.
All right, perfect. So let's dive right into this. This is the profiler software. We're going to look over how to set this thing up, how to eventually import data, and how to make it all work. So Shannon, why don't you take the wheel? It's all yours.
So, like Devin said, go to the support page on moretracks.com, download the profiler software that works with the profiler and the profiler EFI module that we refer to as a PFEFI. It can also be used on the TC3 series for some functionality. And while you're on there, it's worth grabbing the LCD simulator that emulates the handheld through the computer with the USB cord. So it's intended to be a kind of a backup system of different cord, different port, different method, which is on the PC through USB, instead of if you don't have a handheld or your cord's malfunction or you've left it behind or it fell off the pit card or whatever, you can still access your stuff and get through the weekend. Or you may choose not to buy a handheld and just do it all with the PC if that works for you. So anyway, that being said, um,
And I will put in the description of the video the link to the support page.
perfect. So Devin's already got Profiler launched, so we'll just open that up. So we've got a brand new instance of a Profiler file here. So probably the first thing to do is set it up for what your application is. In Devin's case, it's on a Holley. Imagine that. So we go to settings, software settings. Don't make these changes unless Shannon tells you to. Okay. You can do a profiler, which gives you full use of all this stuff over here. But the pre-canned setup, so to speak, for Holley and Fuel Tech and our analog digital controller, the DIC. You can come in here and you drop down, you got a PFEFI or TC3 on Holley. That locks it in. Holley is pre-scaled at 0 to 25 degrees of retard. So that sets this, which is the most important part, so that when we do things over here in the timing, 3 degrees on Profiler is 3 degrees on Holley. For example, if you go to...
So is this something that everybody should hook this up with a TC3?
It's good to do it. The TC3 should come out of the box with a basic setup in it when it's licensed for Holley or licensed for Fuel Tech, but I can't say that works 100%. So
So just do it, right? Just everybody do it.
yes, and even though your TC3 series doesn't have a profile, like uncheck that, you can still use it to download the data and to do your basic system options and that stuff. Back to the timing configuration, Holley is preset for 0 to minus 25 degrees. Fuel Tech is 0 to 35 degrees. So if you had it set here, but it's going to a Holley, it's 3 degrees ain't going to be 3 degrees. It's going to be offset that percentage, right? So you want to make sure this is right. And it's just a little easier to understand as a whole retard platform. Whereas when we do a profiler, it's in timing degrees. Actual, what I call timing light degrees, which you see on the balancer. So on Frankie Taylor's Pro Mod, where the profiler is the only thing controlling the timing, that makes a lot of sense. We tell the crank trigger's at 28. We want to idle at 26. He wants to be at 20 on the trans brake, leave the line at 12. It's all in real degrees. When you factor in something like a grid or a Holley or a Fuel Tech, it's also controlling timing. That gets very, very confusing because the Holley's got 10 degrees out for the boost curve, and the profiler is saying it's at 28 degrees. Well, that's not right, but it's at 28 reference to 32, so it's really retarded 4 more. So you got 10 out on the launch curve and 4 more on the profiler. It gets real confusing real quick. So
Yeah, so this is a timing offset, not necessarily a running the numbers. This is timing offset, what we're used to.
basically, and a profiler.
Right. So all of your changes that you make for timing are going to be
Right.
they're all going to be based off of the base timing.
They're used to anyway. So we're telling the Holley, hey, we're in traction trouble. Take out 10 degrees. So whatever the Holley's already doing, we're going to take out 10 more degrees unless there's some limit that it runs into, right? So you click this, it automatically sets this, and it turns off features that a Profiler EFI module doesn't have, which is the most likely thing a PFEFI on a Holley. You can put a profiler on Holley, and you can have all your events and things back, but it's not the most common setup. So, those guys are going to call me anyway. Okay, so we've got our PFEFI. We've got it set up for Holley. Our timing is locked in. We can't change any of this. Our external retarder, which is the Holley ECU, is set for 0 to minus 25. So then we get into the system options, basically how the car's wired, what equipment's on the car. Okay. So are you going to hook up an arming switch? Hopefully so. You don't have to. You can set the unit for always armed, but you stand a very good chance of losing data because you press the trans brake button to turn the car around, get back under the tent, taking the steering wheel off at the end of the run. The way Profiler works, when it sees a trans brake release, it overwrites the last data. So if you happen to hit the button with the car powered up as you're pounding on the steering wheel with your new world record pass, you just lost the data. So I like an arming switch.
Well, there is some data on the SD card, but I guess we can go over that a little bit later.
If it's had time to save it. In the pounding steering wheel scenario, you probably haven't had time to save it to the card yet. But, so anyway, arming switch is much preferred on a Holley. It's very easy to set up a Holley output to trigger it, say 75% throttle, turn on our arming wire, and it's pretty foolproof. I mean, you're not going to forget to go full throttle for a drag race, and you're not going to let go of the trans brake at full throttle for any reason other than to make a pass. So 75%, 80%, pick a number, works well. If you're foot braking, you got to consider things like I'm only at 40% throttle, but whatever you got going there is up to you. Then you set whether that trigger is going to be a positive or a negative. So when your Holley gets 75% throttle, is it putting out a positive trigger to the profiler or negative? Your trans brake, again, easy to go into a Holley, tell your set up an output pin that follows the two-step or the trans brake launch condition or the rev limiter, the two-step. So again, is it hooked to a positive Holley output or a negative? By the way, if you hover over these things, it gives you little clues. All right. Not active because a PFEFI, which we set this up for, doesn't have a bump box, doesn't have HP3, HP4, HP5, HP6. It does have this that we rarely ever use, but there's an orange wire coming out of the PFEFI. It's going to repeat the drive shaft going into it. On that note, you can split the signal from the drive shaft sensor and run it to the profiler and the Holley separately, or you can run it to the PFEFI and repeat it out the orange wire back into the Holley to an input. A note on that, with recent changes on the Holley firmware, do not run that to an FS type pin. I'll leave that for Devin to cover later. All right, back up here. Do you have a 4-tooth, 16-tooth, 8-tooth, or a 32-tooth ring? Hopefully you got a 32-tooth because you're a baller. And you got that. And then this is a setting that honestly I need to change the defaults in. Ramp in is a speed limit to which is the fastest we'll ever put timing back in the motor. So if it makes a big timing correction, say it pulls 10 degrees out, in Holley speak, actually, it only can put it back in at 100 degrees a second, which is 10 degrees and a tenth of a second. So if we make a timing correction that pulled out a full 10 degrees, When that correction's over, it's going to ramp it in at a speed limit of 10 degrees in a tenth of a second. So it's going to ramp that timing back in, not slam it in. If you check autosave, it will, on the older firmware, you make your run, you turn the car off. When you power the profiler back up with either car power or USB, it will save that run to the SD card as kind of an archive. There's no real reason for it other than, hey, I came back, we had a trans brake problem, we started hitting the button, and I lost my run before I downloaded it. Hey, maybe it's on the SD card. Or as one of my customers, Frankie Taylor, got up in the middle of the night and stepped on his laptop that his kids have been using to watch a DVD with and destroyed his computer and thereby lost every bit of his data. We had the race pack run still on the race pack cards, and we had his profiler data on his profiler card, and we rebuilt from there. You know? Plus, Frankie knows how his car works. But yeah, he got up in the middle of the night, stepped on the laptop, wouldn't turn on the next morning. So, you know, the dumbest shit happens when you're racing. The pre-launch in and out really doesn't do anything on a Pfeffi. On a profiler that works over here, where you may have different timing for spool limiters and pre-launch timing, it's ramping the timing both ways, in and out. This is just in. Event retards don't apply, and that's about it. Launch output, there's a blue wire out of your profiler or your Pfeffi that can trigger other trans brake triggered devices. And it can be a normally where it's, when you're on the button, it's a positive output. When you let go of the trans brake, it goes back to off or ground, or you can invert it. There's a few things out there. I think one of the spaghetti menders boxes, it has to see a ground when you're on the trans brake. So you can do some tricks there. Okay. So that gets you basically configured for the wiring and the setup of how many teeth you got and all that of the car. All right.
All right. So you've preached this to me, and I preach this to everybody when I do videos and whatnot. But we just made a whole bunch of changes, and what should we do? What should we do right now?
I was just going to say it before you so rudely interrupted. Save and save often. You have a quick save up here. Now, right now, we are under the sample default thing. I don't think it will let me save it. See, it wants me to give it a real name, okay? So what I like to do, this is my habit. Let's pretend you're one person, one car, new folder. We'll get Devin straightened out here. 2023, okay? And then I like to go into that folder and create a track. In this case, the track's going to be shop, okay? It could be sick week, whatever, which, by the way, I think Devin just won, dominated, with a brand new car that, you know, his wife, I think, girlfriend built most of. So kudos to her. The wiring seemed to hold up for the whole run, and it was a good deal. All right. So we've got shop, and under that shop, we're going to save a run called shop T1. Now here, you can actually name these as long as you want, what makes sense to you. Hey, sick week with new converter, blah, 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 blah. You can make these as long as Windows will let you. Okay? Save that. This blue default, that's what's called the chart title. I use it as a memory jogger. So I click that, brings up the dialog. You want to keep these short, definitely under 32 characters, but the shorter the better, because the longer it gets, when you upload, this name gets uploaded. By the way, you don't have to put the T1. We'll cover that in a second. You hit OK. When you upload, this name will be uploaded to the profiler. If you have a profile, the built-in screen, the bottom left corner will say Shop T1. So you can get a memory jogger that you did, in fact, remember to upload it. After you got the tune-up done, before you changed the converter and adjusted the valves, and the generator stopped, and you ran out of gas, and the temp blew away, you can go back and quickly look and see, yes, I uploaded it, or my able-bodied companion, Laura, uploaded it, or whatever. The right tune-up is in the car, okay? If you have a Pfeffi, and I have to get used to this, you may not have a remote screen hooked up, and you don't get this little memory jogger. But the other part is when you download, The download is going to be called Shop T1. Then it'll have another designator that you'll see if we can upload, but I don't know if Devin has a box handy. And when it comes up over here in the menu, it'll be labeled Shop T1 with the time and date that you released the trans brake for that pass, which you hopefully could match up to a time slip if the track clocks are right. You know, if they've got their computer time set and all that's happy, and it's a little confusing if you're changing time zones, but you know. So this is important. I stick the T1 on it out of habit because me, like Devin, I'm running around helping 10 guys. Some of them may be in qualifying, some may be in eliminations. It just helps me keep track of runs. But when you actually go to do an upload, which it won't do right now because we're not connected to a box, it gives you a chance to pick some radial buttons, little dots, where you pick testing, or you can do warm-up, testing, qualifying, eliminations, and then you have 1 through 8 or 10 below that. If you're familiar with Race Pack, it's sort of the same deal where you pick the little buttons for which run it was. Then the software tries to keep up with that for you. So when it sees you download, it knows the next upload is going to be T2. The next upload is going to be T3. It doesn't know when qualifying starts, so you got to click qualifying and 1 again, and then it tries to keep track of it. So that way, when you come over here, you've got a pretty organized set of things with timestamps, which I despise when people rename their file and delete the timestamp. I think it's still in the properties if you right-click it. Profile itself may not have it, but it'll be like here, right, of when the run was made. But and a seldom used thing even by me because I forget it's even there. You can put notes in here like your time slip or converter notes or different shit. Okay, getting off tangent here. So you've got that, save and save often. All right. If you've got, we already did that when we set it for Profiler, Holley. That's it. And then there's system options.
So what you're saying is what we just went through is all you really need to do to get this thing up and running and setting it up.
It's pretty straightforward. This video that you're doing now, I've needed to do for years. I apologize for that. I just, my own worst enemy. I've had this exact conversation hundreds and hundreds of times when I could have just recorded it once and referred it to people. There's just always something else to do in a small operation. So,
and here it is late at night, and we're doing it on a Wednesday night.
And I'm loading up to leave for South Georgia at 5 a.m. But Devin offered to do it, and I said, this is a good idea. All right. Little sidetrack, Devin. If you've got a TC3 series or you've got a Pefefi with self-learn, jump over here. Okay. Very confusing subject. I'll try to keep it short and simple. If you have a Pefefi with self-learn or you have a TC3 SL, with Pefefi, you have 3 traction control systems running simultaneously. You have the profile, you have the non-self-learning traction control, which is working on just a rate of change. And then if you have a TC3 SL or a profiler with self-learn, you've got self-learning also working. The difference in these two, this method has nothing to do with a profile, okay? It's only looking at your drive shaft trace for a rate of change that's faster than your car can go. So to put it real simple and basic, let's pretend you've got a 7-second car that goes from 0 to 7 seconds from the starting line at 0 drive shaft speed and 7,000 RPM at the finish line at 7 seconds. Easy math, even I can do it. It was gaining 1,000 RPM a second, linear. Perfect race car, right? So you would set your TC3 that anything over a rate of 1,000 RPM a second is a problem. My car can't accelerate that fast. This 3,000 pounds with this 700 horsepower cannot gain more than 1,000 RPM a second. Physics just don't allow it. If it does, it's most likely spinning since gravity probably didn't change. We didn't get that good of a tailwind, and we probably didn't go down a big hill. So the most likely reason for a sudden, or not even a sudden increase, the most likely reason for my car to be going 1,200 RPM a second instead of 1,000, like I told it, is it's spinning the tire. So now, in a real world, cars don't gain a smooth 1,000 RPM a second. Even a underpowered, high traction car, it's not a linear diagonal line. It's going to be a curve. It's going to go slower as it goes. It's going to gain RPM slower as the car goes faster, right? So, unless it's electric, but that's another subject. So, the self-learning comes into play where you can understand it's pretty easy when you look at like a pro stock. We got 5 speeds. First gear gains 1,500 RPM a second. Second gear gains 12. Third gear gains 9. Fourth gear only gains 7, and fifth gear only gains 500 RPM a second. It's learning every drive shaft revolution, not the last pass, not 3 last passes. I don't give what your friends told you. I'm the one that wrote the shit. So it's every drive shaft revolution. Basically, it's updating its memory, and it's looking and saying, "Hey, right now I'm gaining 1,125 RPM a second." It's doing that calculation between every one of those 32 pulses per rev. So it's looking at a number like, let's say 2,500 microseconds, 2,500 1/millionth of a second. And since you're going faster, you're accelerating, that number's decreasing the time between those triggers. So 2,500, 2,490, 2,480, 2,470, 2,460. It's learned I'm changing 10 numbers every cycle, every sample. Suddenly.
So I don't mean to interrupt, but I mean let's talk about this. This is how fast you're sampling. This is something that nobody else on the market can do. This is a reason why this product sets it away. This is apart from everybody else. This is why I push your product. Y'all have the best traction control in the market, bar none. No questions asked. Nobody samples data as accurately as fast.
To get real geeky, if I remember right, and I'm not the top engineer here anymore. I'd have to call my coder, but we're running a clock cycle at 80 megahertz, which is a 1.7 nanoseconds, 1.7 1/billionth of a second ticker. Tick, 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 tick. We're counting how many ticks between those teeth, converting that to microseconds, so us peons can understand that that's only 1/millionth of a second. We're gathering that data every thousandth of a second. We're polling that ticker. How many ticks went by from one tooth to the next? So you want to talk about how fast we're sampling? We could try to BS it a little bit and say, we're working in the nanosecond range, 80 million times a second. Reality, we're polling that sample. We're checking the temperature of the room 1,000 times a second. The temperature sensor's checking it 1 billion times a second. We're not interested in polling it that often. We check it just every 1,000, see if we need to adjust the air conditioning, right? So, so the self-learning is learning the rate at which that is changing, looking for a sudden deviation from that learned rate. So if it jumps from 10, 10, 10, 10, 10, 10, 11, 11, 11, 11, 11, 10, 10, 10, 10, 10, that doesn't do anything. 10, 10, 10, 10, 10, 10, 14, that's a problem. Self-learning is going to jump in there, pull timing out based on this screen. So we've got self-learning. Let's keep it simple. We're going to go spread 100. You need to change this. I need to get the software fixed. If it's on 10, if it deviates, slips 10 RPM above the predicted, it makes a full correction. Okay, of say, this is a little bit confusing. In real time, I'll explain. I don't want to get too far off base here. Sensitivity 5 degrees, only when armed, real time. This is Devin's drag week, sick week car cruising down the interstate with his trailer behind him. He can ride along all the time that he has it armed with a generic universal traction control setting of sensitivity 5 and 5 degrees. Realistically, 15 degrees in this scenario, right? he hits a pothole, he hits a slick spot, whatever. It triggers sensitivity 5 that there's a gain of acceleration that's a problem. It's going to jerk out up to 15 degrees. If it goes 100 RPM above the predicted RPM. So if it goes 50 RPM, it takes out 7.5 degrees. If it goes 25 RPM, it takes out 3.75 degrees, right? This sets the linearity of this max retard. If it's at 10, it's a 15-degree toggle switch. Every little thing is going to take 15 degrees out. And you're driving down the boulevard, and your car's going, what the hell's wrong with it? Okay, so for that reason, you don't want to run self-learn while you're dragging your trailer behind you or cruising down, okay? You would uncheck this box, which you can do on the handheld. You can do here and re-upload. You can do with the software that emulates a handheld. You take it out of self-learn, run it like this. So now Devin's in his drag week car, and here comes Cletus up beside him and wants to goof around. If Devin jumps on it and gets a little squirrely, he's still got a real-time traction control system, just not letting his tires gain 3,000 RPM a second, okay? He gets to the strip because all he's got is a TC3 SL. He turns self-learning back on. He doesn't have a profiler. And it's running on these settings here and this setting. If you get above the 100 RPM and you have smart drop enabled, let's say you got level 3, at 101 RPM, it will start dropping 1 out of 8 holes. At 50% of this 100 RPM spread, so at 151, it will increment to the next allowable level, 2 out of 8. At 201, it'll go to 3 out of 8. At 500, it's still going to be 3 out of 8. That's as high as it's allowed to go. I don't want to get too far down this rabbit hole because this is self-learn, but there's some quick information might give some guys some ideas. Now, if you have a profiler with self-learn, I want to touch on this and we'll have to circle back, maybe another video. If you have a profiler with self-learn, when you release or TC3 SL Pro, which is professional, not profiler, by the way. If you have a TC3 SL Pro, it then uses zones. On this screen right now, we have one blue zone, and we have zone settings in which you set a TC sensitivity and a retard per zone. Now we have more zones, right? We'll get back to that. So as soon as you let go of the trans brake, this gets overridden by this column or row here, okay? If you have a TC3 SL, it works on this screen, which is also on your handheld or in your handheld emulator through your PC. So wanted to touch on that because it's a loaded subject. All right.
So we've got traction control already working, ready to rock and roll. Let's set this up as if we have 0 runs prior to this, right? So this is a new car. Let's just say it's a brand new car. They've never been out before. What do we do? How do we set this thing up? Do we don't want to build a profile? Okay. We don't have run data already. We don't have a drive shaft curve already. Let's just work off of a baseline to get somebody to go out there and make a pass with their car, gather the data, and move on.
Right. And if we've got no previous data to go on, we have no previous profiler data to go on. Okay. Couple things you can do. If you got race pack data, you got grid data, they're very easy to import. That's another video. Devin made a video on importing your Holley data. It's not as easy, and I did it once, and then I tried another file and I failed at it. It's temperamental. So in that case, without telling guys, look, don't get too hung up on that. What I do is I help them come in here and eliminate a bunch of these dots. Okay, again, we can probably follow Devin with a little tips and tricks sort of video, and then just go to one of your previous Holley runs, and for the first 2 seconds, manually enter the data right here. Type it in.
So let's just say that they don't have anything, right? You know what I mean? Like, what do? We just turn on self-learn, let it rip, and see what it does.
Right. So so you can try to create a profile through old data, or if you have self learn, I recommend, hey, dude, turn it on. Let's get a basic self learning tune up in this thing and let it help you make that first pass. If not, hey, this is a 440 car. I'm gonna put a 480 tune up in it that'll go down anything, any day, and we'll start there. So you do that, and let's say we've already done that, and we just happen to have that run saved. So wait, let me back up. You'd go and make that run, come in, you're going to come in and you're going to download your profiler. You're going to pull the data out of the car, from the car down to the computer. Okay. And then later you're going to take and you're going to change that data and create profiles and all shit. And you're going to upload it into the car. Okay. Pet peeve of mine, as you can tell. All right. So you So you made a pass, you come in, you download it, and you'll come back with something like this. We're going to bring this. This is an import of old data as run data. So now we have a pretty line on the screen. By the way, this is what your drive shaft RPM should look like. Okay. It doesn't look like you put 97 points of smoothing on it. This is data sampled 1,000 RPMs a second, 1,000 times a second, plotted at 400 samples a second. Okay. If we look at this, it's every 2.5 milliseconds. It's 400 samples a second. This is what Devin's car did. Leaving the line, I can absolutely guarantee you from right about here, this is real data. Okay. Here, yes, it's a little erroneous because you're just getting triggers going. It depends on where the sensor's parked, where the trigger ended up. Was it right at the edge of the sensor? Was it dead in the middle of the tooth? How quick did he get those first couple? What did the car do? A couple things. But once you see it start doing this is real data. So this car kind of left and went, rrr, rrr, rrr. I doubt if you watched video footage at a quarter second, the front tire is probably just back in here. The front tire hadn't moved yet. The fender's probably separating, but that's about it. All right. So he's got this data. This is what it looks like. Yes, it did this. That's a tiny bit of tire slip right there. Here it's working that tire a bit. It's not getting in trouble, but it ain't dead hooked either. There's a gear change. Jerked the tire up, came down. Then it slipped and fault that tire a little bit after that gear change, and then settled down and went on. This is where it could have chose to get away from you. This looks like a little spike of bad data. Don't know why. Probably poor wiring, bad guess. No.
Probably poor wiring. It may actually be another gear change. I really don't know. I haven't looked at it thoroughly.
Could be. Every now and then we will get a little, very rarely, but every now and then profiler can get a little weird data. Sometimes if you've never had this is just things I've learned. I don't want to get too off base. You've never had this, and all of a sudden you got 3 of these. Make sure all your spark plug boots are snapped on. It could be something that simple that it's never done it before. It only did that one run. I'll almost bet you get a spark plug boot wasn't completely snapped on. Car ran fine, fired every cylinder. EGTs looked good, but there was a little teeny spark jumping from that clip to that plug terminal, and it picked up a little noise right there. Could be. Because you see, there's only one in this whole run. There's, I don't know how many, I haven't done the math on this, how many hundreds of thousands of samples it is. It's 400 a second for 7 seconds. So that's 2,800. Is that right? 2,800 samples. We got a bad one. Out here, I don't know if this is bumps in the track, or you're letting out of it and kind of bumping the throttle, soft run and kind of goosed it a couple times.
Yeah, that's probably shut down and like letting out of the throttle. I believe that run went like a 468 or something like that. So it's probably just lifting off the throttle and bumps in the racetrack.
Right. So to get to the meat of this video, we have our thing. We've got some data. We're going to save and save often. And we're getting ready to make our first run. The easy way to do it is go to create profile. Do you want a copy of this profile? That's just the default one. You can hit copy and you can name it profile copy or Devin's first attempt, or that's just going to be a copy of this old one. Okay, we don't need it. Click through that window. Grip interval. I've got 400 samples a second. I've got data at an interval. I want to put a grip on every 10th data point. Okay, it's going to look like that. That's frankly enough. Okay, it's 40 dots a second. There's an averaging applied, and just the fact of having less dots kind of averages and smooth things out. But as I change this grip interval, if one of these two dots, due to the interval, happens to land up here, it's going to go up there with a little bit of averaging smoothing applied, right? So I can do this, and you can see kind of how it behaves, right? I've only got a few dots, then it's just a pretty smooth, generic line. If I crank that down, less interval, less gaps between grips, you see it gets real dense. That's 200 dots a second, okay? This gets hard on your computer depending on how much computer you got. Because every time I try to move one of these, it's applying math to all of it to smooth and average and do shit. So we're going to run this back up here, back to 20, run that back down to 10. So that's your grip interval. 10's a real good place to be. The averaging, if I turn it down, it'll follow the plot a little more accurately. If I give it smaller grip interval, it'll follow it, eventually just dead on, right? Again, gets a little hard on the processor, and you just don't need it. We can do it. We can do more dots than this. We can add dots in between all these. But I like 10 and 3. That's just a good place to be. Okay. If we had multiple runs, we can bring them in here and average them together. So I don't want to get too far down that road because that's a separate video. But let's import one of your other ones. Bring in his run data.
Yeah, that might be the same. That's around same.
I believe it's the same piece of data.
Yeah, it's the same run. I just renamed it.
But to show the accuracy of our recordings and plotting, there's 2 runs there. So, all right. Anyway, we can take those 2 runs and average them together. So we create profile, and we've got 2 runs selected on the screen, and we can average them to the upper part of that average, the very tops, the lower, the middle. Something that's actually pretty handy. Let's just go back to our 1 run, okay? But
yeah, so
I want to make it.
So show them what you.
This was a base run. We want to go a little faster. I can go here.
So show them what you did there.
Oh, I made it smaller.
Yeah.
So you can drop this arrow down.
Yeah, and change your size.
I can make them where they're easy to get a hold of and drag around, and do things with manually. Or I can make them smaller, a little more detail, or I can just click the button and turn them off, and I still got the line. So now I want to take this, and for exaggeration measures, I'm going to make the whole thing 200 RPM faster. 200 RPM is a real big deal down here, not so much out here. So a better way to do it is, hey, that was a real soft tune. We want to step it up a little bit. We're going to go 50 RPM on the whole pass. You can't even see it until you zoom in. Okay, it's 50 RPM above. Now, those of you that are used to your grids or maybe other systems out there, this is what you're used to, is running this thing 50, 100 RPM above so it didn't false trigger. We don't do that. We don't false trigger. Okay, we're measuring RPM extremely accurately. It's not going to false trigger unless it crosses that line for real. But let's say we go 50 RPM, because 50 RPM is actually a pretty big deal early in the run. And then what I think is a really cool feature, but I want to go 3% faster. That applies 3% to all of it, which is very little down here. Now we're 51 RPM, but you can see it exponentially allows more and more and more speed, which is also what your car is going to do. If it's 60 is better.
Yeah, so if you were following along during sick week, we were going exponentially fast, or we were picking up every day. So I think we went like a 68, a 63, a 60 flat, and then a 59. And this is one of the things that I used, to offset to allow that.
It's also a handy tool when you break your 410 gear and all you can borrow is a 488 and you're rethinking the world. You can use this to at least get a theoretical profile. Understood, the car is going to accelerate and behave differently, but maybe it's just a smaller change than that. And it's like, shit, we know that we got a taller gear. Maybe you call that a taller gear. It's going to turn more RPM and go the same mile an hour. We're going to run over our old profile. It's going to slow us down. Well, instead of just guessing and dragging it, now I've got videos on the More Traction support site to get into using the software more. I don't want to waste Devin's time on how to edit profiles and all the things we can do. This is more of a first setup theory. So there's some stuff there. So now we've got a plot. Okay, so what are we going to do about it? What's our tolerances? Now I'm going to go back here and I'm going to start from scratch. We have one zone, we've opened the software up, we've got one zone 0 to 7 seconds, and we've got maybe we're going to turn those off for now. So we've got our profile. Okay, here's our target drive shaft, here's our actual drive shaft. If it goes above this target, we want it to do what? Or how aggressively. That's your ranges. This is your rainbow. Okay. We have our target drive shaft with the dots. We can make those bigger to see them. If we start getting up in the green, we're going to start pulling timing out linearly. I pronounced it correctly, I think. From 1 RPM over, it's going to start pulling timing up to the top of the green based on a 50 RPM spread, tolerance level, margin is a good word. I can make these as wide. Okay, Frankie Taylor Pro Mod, 100, 100, 100. Okay, normal runs move 100 RPM, no big deal. Brad Edwards, pick others, radial. And Pete's got some videos out that he's shared some of his tuning tips. But I certainly work with radial guys that something like this is the norm. If it goes above 1 RPM, I want to start pulling timing. By 10 RPM, I got a couple degrees out. You cannot let that radial get a run. That's where other systems on the market are very lacking. They don't even measure RPM accurate enough or fast enough that you don't just have to run your first line 50 RPM above or you'll false trigger. Well, you let your radial get 50 RPM out of whack, you're already in deep shit. You got to pull a lot of timing or something to fix this. So, I think really, a lot of guys I work with, I'll start their first radial pass at like 20, 20, 20, or we can use this red zone a little different because it's got some arc drop in it. So say we did this, and then these below, we can add timing. Okay. So let's layer those up a bit too. We'll be a little more lenient. So now we've got our target drive shaft. We've got our margin of error we're going to allow. And then we've got, what are we going to do about it? That's our zones. We come to a zone. Okay. In the first one, in the green, we're going to take out X many degrees. In the yellow, we're going to take out more. In the red, we're going to take out more. Important note, these do not add together. That'll make a little more sense in a moment. Smart drop limit. Traction control or self-learning traction control, right? Rate of change traction control or self-learning rate of change. The reason I'm not filling this in right now is because I want to show the zones. I want to show full screen. We're going to add some zones. We're not going to run one setup the length of the track. I'm going to do a dead zone at the very beginning. So we're going to add a zone. We're going to add a zone. We're going to add a zone. We're out of zone. We're out of zone. This first one, I'm going to run like 0.04. It's going to stay all zeroed out. To look at Devon's specific data, turn that off. We'll zoom in here. I'm using the scroll wheel to do that. We'll turn the ranges off. His data kind of calms down and starts being real data out of here somewhere. Okay. So let's take this guy. We're not going to touch it till it goes that far. If you can't get a 1/10 of a second on your own, you might look into another hobby, right? So it's up to you to get the first 1/10 of a second. I really just don't want to add timing because it thinks it's slow or it thinks it's fast. You could also move the profile through that area. You could manually just drag all these up here, and kind of default it that way. Now, if you have add, it's going to try to add because it's below the line. So it would be doing whatever's in these cells. But a couple ways to skin that cat, right? Easiest way, dead zone. Okay. Now, if you look at this real closely, there's 2 zones here hiding. Drag this bigger. Okay. So then let's take us a zone out here, 60 foot. Is that?
Yeah,
I don't know what you 60 foot.
No, we went.
But probably around.
No, we went 130 because we were on like a tiny little tire.
So let's do 130. All right. Now, since we have actual car data, at least for the first gear change, turn these off. Put a cursor right here. See this? Here's a little sidebar. Here's your current cursor spot, right? See that little teeny arrow? Drop that out. Drag this where you want. So 180, right? 1.8, 1.9 is this right before his first shift. I like to do this. 1.8. Okay. To 2.0. This is my shift zone. Right click. Change it to electric aqua. Right click. Rename it. 1-2 _ shift. Just so I know that's a shift. With detailed data, you will learn that every car in the world does this. Accelerating. Some transmission guy can explain this to me, and maybe that's Devin. I'm assuming right here it's decoupled first gear. We're coasting. Here comes second gear is now coupled, engaging, and yanking that drive shaft, right? So you don't want to drop below your target and start jacking timing in right here just to make sure you blow the tire off on the gear change. So if we were adding timing back here, we may not want to do it in the shift. Maybe you do. Maybe that's the speed secret of the new millennium, and you're going to put 10 degrees in right before the shift, and it's going to go like hell. I don't think it's going to. It's a bold strategy. See how it works out for you. So, all right. So we've got our shift zone, and then if Devin had, real data, let's say shifted somewhere out here. I'm guessing it'd be out here somewhere. Let's call it 3 seconds. We're going to run this out to 3.0. And then we're going to add one more zone, which will make sense in a moment. 3.25. I put a comma instead of a point. So it's mad at me. By the way, my overseas customers like Sweden, they got to put their keyboard in English, or they use commas for decimals, and it really breaks Profiler. Not happy. So I'm going to add one more zone yet. Devin, you hope to have like a 6-second car, right?
Yeah. I think it went 460s or something there.
Okay, so now we have, let's call it 550 here. Okay. No, I'm sorry, I did that wrong. This is another shift zone. This is why I like changing the color. I just had to figure out where it was at. Do that. Rename it. 2-3 _ shift. You might be able to use a space there. I don't remember. Okay. Then we got the end of our pass, hopefully is over by 5 seconds. And the end of our run We've got our max time set for 7. I like to run my profile, my zones, basically give this thing some direction in life. If you just stopped it at 5, computers being computers, it may decide to do its own fucking thing out here because you didn't tell it what to do. It's a little bug we see every now and then come up in Holley. If we don't give it a timing dot, it may decide to go minus 25 degrees. It's usually not a real world problem because you shut the car off, and it's random and we can't find it, just to be honest. Don't know if it's on us, on Holley, but it's on us because it does in other systems as well. But anyway, now you notice we have 2 zones here that are nearly the same color. Right click, zone color. We'll make it green. And other people may like this. You can darken these up to whatever floats your boat. Okay. So there we've got our target drive shaft. We've got our tolerance levels, 20, 20, and 30, 40 and 40. Okay. 3 retards, 2 advances of what we're going to do if it deviates from this target drive shaft. And then we've got our zones, which is what we're going to do in each zone to correct the problem. Don't let it overwhelm you. If you know how to work one zone, you know how to work 38 zones, right? So we're coming here. First pass, we're going to play around with, hey, let's just add 1/4 and 1/2. Let's retard 1/4, 1/2, and up to 3/4. Okay.
So is everybody noticing what's happening there? As you modify the retard zone 1, it also modifies retard zone 2 and 3 because it won't allow you to like retard, say, 2 degrees in zone 1 or in range 1, but then only 1 in range 2, right? It has to grow. It has to be a larger retard every single time that you step up. So you basically can't screw it up. It just does it for you.
Hopefully screw up. Hopefully so you can't screw up. This is not 6 degrees total. As it travels through the rainbow, as you're riding the rainbow, by the way, we may get some riding the rainbow shirts for those of you that want to really support Profiler Nation. First time I tried it wasn't a big hit. None of the Pro Mod guys would wear them. So Frankie just refused to until he went 348. Then he said, I'll wear it. So anyway, as it deviates from this target and starts going above, it will retard up to 1 degree by the time it's 20 RPM too fast. So right here, it's at 1 degree retard. Now it's going to go from 1 up to 2, and then from 2 up to 3, which is actually at a slower rate of retard. Okay. The red also gets into our smart drop. Let me give this an easy number. Okay. To explain smart drop. Smart drop limit. If I go smart drop limit 4, we can lose up to 4 out of 8 cylinders. As soon as your drive shaft touches the first quarter of the red, it will be retarding whatever the retard level is. And in the first 25%, as soon as it touches it, it will drop 1 out of 8 cylinders. When it gets to 26% of the red, it will be touching the second quarter. It'll be dropping 2 out of 8. 51%, you're actually into the third quarter, which runs 50 to 75, right? So it's dropping 3 out of 8. And then as soon as it touches the fourth quarter, it's dropping 4 out of 8. That's real cool when you do this. Now we're only going to drop 2 out of 8 max. So the first quarter is retard only. Second quarter retard only. 51%, you're touching the third quarter. We start dropping 1 out of 8, then 2 out of 8. It goes up here to the moon. It's only dropping 2 out of 8. Okay. So if you're like, man, I really don't want to drop cylinders. I got a Pro Charger. I'm worried about my drive, or I've got a nitrous card. If I drop a cylinder, it'll blow up, which it won't. Just ask some of my street outlaw guys. And you can do something like this. I only want to drop 1. If I get in real trouble, I'm willing to drop a whole, but I want to be in real trouble. I'm up here 20, 40, 140 RPM, just shy. Let's call it 100 RPM before it starts dropping 1 hole. And then, hey, and you can even get real crazy. I'm going to run it way up here. If it gets stupid enough, I'm going to drop 2 holes, which has a real ability to get its attention. So you got to play with this. Again, not trying to get too much into a tuning video here. What I really don't want to see you do is this. 20, 20, 20, 1, 2, 3. You're retarding 1 degree every 20 RPM, it gets in trouble. You could have done the same thing with a 3 here and a 60 here. It's the same 1 degree every 20 RPM. The idea was to get exponential on its ass, right? Get meaningful. We're going to tickle it with a degree over 20 RPM. The degree didn't do the job. Let's get it realistic. We took a degree and a half out. That didn't do it. It helped, but it didn't fix it because it got up to the yellow. Well, through the 20 RPM of yellow, we're going to go another degree and a half to 3 degrees, right? Or we're going to go up even exponential. We're going to take another 2.5 out. So now we got 4 degrees. 2 things are happening. You're taking timing out at a faster rate of retard per RPM, and your motor's less happy with 4 degrees out than it was with 2 degrees out. It's also kind of exponential. You get 12 degrees out, it's pretty sad. You get 15 out, it's real sad, right? And then you can get real crazy. And if that don't do it, I'm going to take 10 degrees out over the next. Maybe you got a 40 or 50 there because you don't want the smart drop being too toggle switchy. So you want to be 20, 40, 60 in trouble before it ever starts dropping a hole, and that's early in the run, your 60 RPM. We can't change the range width down through the run, but we can change the retard levels. So it's kind of this different way of getting the same thing. Maybe further out, maybe through this section, I'm really worried. This is when my power's really coming in. If it starts getting too spicy, I'm going to get after it, So you set up each zone to what makes sense. How much you want to add, we cannot add above the Holley or whatever system's in front of it. We can't move the crank trigger. We can only we can only add timing if we have timing out. So to sidebar a little bit, me and Devin and people helping you tune will try to talk you into moving your launch curve, your tire management timing, not your boost curve, not your nitrous timing, your launch curve. And an easy way to do this, right click, show data. I'm going to jump big here, minus 10 degrees. Okay. We can close this now. It's off the screen, zoom max. Okay. So we're going to leave the line. We're going to jerk 10 degrees out. We're going to ramp that in. We'll do this real quick and crude. We're all in by 2 seconds. Once we get to 2 seconds, I don't care what I type in these ads, it can't do it. It's already at 0. We can't go above this line. Okay. We can only put timing in where we have it out. So here we got there, track's way better than we thought this no prep backwards track shit was going to be. And it stuck the tire. It's way slow. And the whole pass is going to suck, except thank God it added 2 degrees and picked me back up. So your timing window just got, in say this case, you just gained a 7 degree kind of lazy man's timing margin. Your job is now switched from how much timing is going to give me a wheel speed I think this track will hold to I think this track will hold this much wheel speed. Here's the rough timing curve I think will do that. I know it's not going to leave at 0 retard. I gotta pull out 8 degrees to have a chance of this car leaving the line. But if it starts getting wrong, I can take out 5 more within 60 RPM, 10 RPM if you want. And if it's slow, it can add some time. It gives me a up to 6 degrees down to minus 12, 13 in this case. So you come back and you download that and you got to run. and it did great. Devin, I'm gonna try something weird here real quick. Hold with me just a second. I'll try to drag a picture. The thought was on my desktop. I don't want to waste any time on this. Devin, you may have examples you can post up or stick in with something, comments. So when you're doing this right, when you're riding the profile, that timing on the bottom is constantly busy, adding and removing timing.
Yes. So this is a little thing that I do quite a bit. So just like Shannon was saying, you can't pull or you can't add timing that that beyond what was already there, right? So it has to be removed. So we may run a like let's just say right here like a 4 degree retard, like run curve retard the whole way, so that we have the ability to add those 4 degrees back in. So we have 4 degrees out along this run, and then we'll come into our zone that we're that we're working, and then we'll put those 4 degrees back in it, right? So we're automatically trying to slow it down no matter what, but we're giving the profiler the ability to add the timing back in. So most of the time, these cars, turbo cars, I do this with turbo cars most of the time, but most of the time the turbo cars we're working with boost control ramps, right? So like it's the how we're bringing boost in. So if we knock 4 degrees out of it, but we allow the profiler to add the 4 degrees back into it, it's literally just going to be a zero retard, and then we as long as everything goes well, right? But if we're ahead of the curve and we've already got 4 degrees out of it, we should be a little bit better shape. So hopefully that makes sense to y'all. That's the way I would run the advance for a turbo combo.
Yes. So yeah, there's a lot. You can do that and just open up your tuning window. What I was getting at, I'm not finding the picture I wanted, but it's and y'all may have seen it. I've posted it a couple times. I've got more examples here. Devin's freaking me out. I'm under pressure. I can't find it right now. When you're riding these dots, this timing down here is just busy. It's just constantly add and remove, add and remove, add and remove, add and remove. If you want to go faster, move that profile up a little bit. It's automatically going to add timing and go faster if the track will take it. And you've got this nice high resolution data that's showing you all this stuff. So you get this. This is kind of your first step. Now you've got to run. Usually 2 or 3 passes, you're starting to really get the hang of this, and it's pretty good. Devin, if I can do this, if you click the Davis logo in the software, it'll take you to the website. You go to support, which I'm failing at. Good Lord, hover, son, hover. Profiler software tutorial. There's 5 videos here, 4 videos here of me babbling at the screen, but you'll learn something. Like right here, here's almost what I was trying to show you. It's in trouble. It's pulling timing, adding timing. That's that gear change right there. That's a self-learning correction, jerking that down. Now it's adding time. This is what a profiler run looks like. This was a no prep. This is actually Caitlin Morton. This is where it's jumping out of gear because she's holding the shifter and in gear. She was the first person with balls big enough to try self-learning the night we got it working. She was racing Megalodon and said, I'm going to get beat anyway, so what have I got to lose? And she won. This was the previous pass, blah, 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 anyway. But there's these videos. Here's another example you'll see. These are gear changes. But you can see it's just constantly working that timing. That's what profiler looks like, okay? These videos are getting a little bit of age on them, but Mike Lucas, one of my first customers out of Nitrous Pro Mod, before there was ever any instructions, he had one of the first profilers out there. Luckily, he wrote technical documents for Xerox Corporation. So he said, hey, I'll write the manual for me. So he wrote a 176-page manual. and did these videos. They're still pertinent and they're good and they're much slower than me, which is good. If you're not using a big profiler with events, you don't need this. If you got a smart relay, this is a good video. But if all watch these videos, it saves me and Devin on the phone with you explaining how to move a dot. No offense, but come on, guys, put some effort into your race cars. You just spent a lot of money.
The other thing is like, you kind of got to be reasonable with your tune-ups too. You can't put a tune-up in there that's supposed to go 4.0s on a racetrack that's not going to hold anything faster than like a 480 or something. So you have to be reasonable. That's why these videos are hopefully helpful to you, but you got to be reasonable. You can't just swing for the fence every single time and then rely on this.
Right, it had no chance of working. And hopefully if it did spin, we're pulling out 9 degrees the whole fucking time, like you told it. And it just didn't work. So another sidebar, this was done pre-PRI for a different reason, but y'all may find them very interesting. They're on the blog. They're not on tech support. It's an overview of our stuff versus some of what's out there. It's a comparison of our stuff versus what's out there, real time. Holley, Fuel Tech, Grid, Davis, all running on the same runs at the same time. This gets into the TC3 and the self-learning stuff. Maybe this is the lifetime comparison. I'm sorry. Overview, more about Profiler, TC3, and then all the systems running together. And then if you dig through my Facebook, some interesting shit happened at PRI that'll really make you say, yeah, Davis is just better. Because while we're there doing live demonstrations, one of these systems, not to mention any names, was just doing its own thing every now and then and just retarding for no apparent reason or not retarding for no apparent reason on runs that the other 3 systems are doing exactly the same thing every time. And it's got to do with the way they sync up at the hit of the run, which gets down to the fundamental core shit of if you can't start at exactly the same thousandths as you get down the line in that profile, it's essentially shifted. If I take this data, like on Devin's right here, I can do this. Devin may not know he can do this.
No, I didn't.
If I move this, it's suddenly now above a profile that it shouldn't be above. I've only moved it a few hundredths of a second. Okay? But look at the effect it has. So if my other system starts a little bit late, 100th into the run, then all this blue data is coming 100th of a second sooner than intended. And by the time I get out here, it's running over the profile. So what this other system was doing was getting out here and just retarding the whole back half of the track. But why did it do that? Because it synced up late, because they didn't take this point right here real serious. We take it real serious. That's why your big profiler or your Pefefi with a screen on it, the screen blacks out when you hit the trans brake. That's on purpose. You can't communicate with it if it thinks it's on the trans brake. Its only job in life at that moment is 1,000 times a second looking for that trans brake release and starting this sync within 1,000th of a second, so that all this matters. That's how we can run 5 RPM margins and not make false corrections. If the car does the same thing. So, there is a difference. It's not just me wanting, beating in my chest about my stuff. You watch those blog videos, you'll see that he's not full of shit. The stuff really is better. There's a reason why a lot of cars that certainly can run the systems that are built into their EFI also have profilers on them, and they have to be some of the bigger names in the sport, the ones you hear about, the ones that are setting records, save and save often. That's that little quick save. For you young guys, this is a floppy diskette. Okay. This is actually a very new floppy diskette. These were hard, little 3.5-inch disc. No, you click that. If it flashes orange, it just saved it. So as you make changes, we don't have Control Z or undo or go back. There's a reason for it. It's not because we're lazy. It's honestly because there's so much data. And early on, this has grown beyond anything we ever thought it would. And but this create profile tool is extremely powerful between rounds. Again, those other videos will show you how to use and manipulate the software and the dots that you can actually use it. One of the complaints with other systems is that there's physically not time for Devin to spend 10 minutes on his profile or 30 trying to individually drag dots and type in RPM offsets on individual data points. Some of these other systems only have 20 data points for the whole run or 16. I think, let me rephrase that. Most of these other systems have 32 data points for the entire run or less. And they don't have tools that make it easy to do because you got valves to adjust. You got a pro jack that ain't working. You got a generator that's out of gas. You got a dog that shit out in the pit mat. It's just racing. And it's these tools I'm pretty proud of. Just what we have at our disposal to quickly and easily create the profile. Again, your job has changed from what power timing map do I think is going to result in this drive shaft. To flip that coin a little bit, this drive shaft and eventually a whole library of drive shafts over here is what I can run on that 120-degree surface in this air today. And here's the timing curve I think is going to get me there. And these tolerances and corrections are going to fine tune it to run that dot. If I drag these dots up here to an unrealistic level, 4,000 RPM at 1 second, it's probably going to spin. It's going to do what you told it. It's going to jack timing into it, trying to get to 4,000 RPM at 1 second. That's pro mod numbers, where they should be at 3,000, 3,500, trying to get to 4,000. It just ain't going to do that. This mass will not accelerate this fast with this much friction. It just won't.
And don't judge me too hard here because we were on a tiny little tire, right? And the numbers he's talking about are legit pro mod numbers, right? So being on a little 235 radial, we can't accelerate nearly as fast as you can when you're on a big tire when you're not really traction limited.
They jump. Frankie's car will leave the line. It's immediately the first data point's at 1,500. And then it lofts up if it's fast. And then it comes down about 1 second, 1.2. And right here, it's either going to shake or it's going to go. It might quiver. You get away with it. It's not going to be fast. When we ran the 348 at Rockingham, that was actually the first pass in history we allowed it to add timing. It added timing most of the 60 foot. Up to 2 degrees. The video I posted of Paul running around literally in tears, he told me it'd run a 52. If everything aligns, 51 certainly possible. If everything is perfect, we might get a 50 flat. And it went a 48, and he just could not believe it. It was the first pass we ever allowed it to add timing. And it started to quiver, added timing, and didn't shake, didn't quiver anymore. And the result we never repeated and it was killer air, killer conditions, tailwind, killer track. I mean, it just, everything had exactly the right tenth of a PSI pressure by coincidence. It was all lined up, I don't think anybody's ever questioned the number. It's just, lots of 50s, harder. It's just everything went perfect, probably staged a little shallow. Just everything was lined up, but anyway.
Well, so hopefully we got everything covered for everybody to kind of just get this thing up and running for them.
Yeah, I got a little winded there.
Well,
apologize.
It's not that big of a deal. We just we want to try to stay focused on what we got for these people to learn how to use their profiler, and in hopes that they can get out there, make some hits, gather some data, learn their race car, learn how to accelerate a little bit faster and a little bit more consistent every single time.
Hopefully it recorded and the mics are working.
Man, I really hope so as well. I'm kind of afraid to turn it off. We've been at this for a little bit over an hour, and
all right, buddy.
And if I gotta fix this, I'm gonna be bummed. So I'll see you.